Good afternoon, ladies and gentlemen. So we are on the way to bioeconomy, which we will, according to the vision of the Confederation of Pulp and Paper Industry in Europe, we will reach before 2050. It means that we must get the highest possible value from the fiber resources. And the focus on sustainable, renewable and recyclable materials will increase the demand for wood fibers, so that there will be a shortage sooner or later. Recycling is an efficient way to save virgin fiber raw materials and extract more value added from the fibers, more added value from the fibers. So recycling will be an essential part of bioeconomy. Recycling is already important now, but it will be more important in the future. Also, the recent trends show the increase in recycling rate in Europe. We have reached 70% level already, and in order to maintain the recycling rate on this level and even increase, we have to face several challenges. Higher recycling rates will reduce the quality of recovered fibers and paper. There will be more non-fiber components. An additional trend is that, and that will include that there will be also more recycling or deinking waste. An additional trend is that there is going on that there are more deinkable papers in the market. So papers printed with flexo method or inkjet method. With certain paper grades, it's already the case that the virgin fiber coming to the market is already very low, and many paper mills already have been closed that will produce virgin fiber-based raw materials and paper. And finally, the potential problem is also that the paper and fiber has a quite attractive heating value. So would be attractive to burn the fibers, even when it would be better to recycle. I will show some recent research results related to recycled fiber, what have been obtained during recent years. So the certain printing methods like inkjet printing is not quite suitable for conventional recycling or deinking process. And there should be new methods sought how that could be solved. We have found or studied possibility to decolorize the inkjet ink by using lac gas, enzyme, and mediator. And like in this figure, we can see that especially with the red color, magenta, the decolorization is very good over a quite wide pH range. Also, the black ink shows attractive decolorization. So basically this shows that with suitable combination of enzyme and ink, nearly 100% decolorization can be obtained. And this is interesting result when we are considering new deinking or deinking methods. Not just deinking can be problematic, also the recycled paper and in higher recycling rates can cause problems in the paper making process and and cause problems in the product quality and also in the runnability of the paper. Here are some results from our study, which was 1 month long follow-up study in one newsprint mill using 100% recovered paper. We followed 89 factors and looked their correlation with the runnability and paper quality. Especially we concentrated in the stickies, and we used 2 methods to evaluate the amount of stickies. So we used THF soluble stickies. It means that part which is soluble to tetrahydrofuran, and another method was we called macro stickies. So it's some kind of conventional method to evaluate stickies. One of the first interesting results was that we found no clear correlation between these 2 kinds of stickies. A statistical model was built, and it quite nicely seemed to be fit to the result, experimental results. So here we can see the red line showing the what is the prediction of the model. In short, we can say that the result shows that THF stickies, not those macro stickies, and the origin of the recovered paper were clearly connected with the number of web breaks and the downtime in the paper machine. With chemical pulp, it's known that the fibres will suffer from hornification, which means the swelling ability of the fibers will be reduced with recycling, and additionally also the bonding ability. The bonding ability of fibers can be improved by chemical methods, and like here we see some examples that like xyloglucan can considerably increase the strength of the virgin paper, in both cases with never dried and once dried pulps. But interesting thing is that the improved bonding ability will stay with the fibers also with recycling. Like here we can see the strength advantage even after 2 recycling cycles. Okay, back to the idea and to the road to bioeconomy. What should be done? We should more concentrate in the recyclability of the paper and design paper also for improved recyclability. We could call that eco-design. Also, it should be possible to divide the costs and benefits in virgin fiber and paper production over the multiple cycles. And the first step would be to have a life cycle analysis showing the like carbon footprints over multiple recycling cycles. We should have methods better to evaluate the quality of recovered paper and fibers. We should develop better sorting and fractionation methods which should reduce the recycling waste and find valuable uses for the recycling waste. And develop criteria for recycling paper once more instead of burning it. And VTT is actively looking for cooperation possibilities in these areas, also in regarding future EU calls. So thank you for your attention.